All right, we're going to start with number 7, pick up where we left off. This is in 3.3 notes. First thing that I want you to notice is, remember, we're trying to, as best we can, get everything to sine and cosine, but sometimes that doesn't necessarily work out the very best. So kind of look at what you have. We've kind of talked about the possibilities. First thing that I want to look at is these two guys. The reason why I'm looking at these two terms is because when I look at my Pythagorean identities, I have tangent squared theta plus 1 equals secant squared theta. So the thing that I can take away from that is if I move the tangent squared to the other side with secant squared, I have this now. And so when I'm looking back at the problem number 7, I have that secant squared x minus tangent squared x. So that can give me 1 plus, and I still have the secant of x. So that side I did a little simplifying. The next side I'm also going to do some simplifying as well, and I'm going to break this fraction into 2 separate fractions. So I would have cosine of x over cosine of x, and I think some of you can simplify that down right away. And then I also have 1 over cosine of x. So this red side, or the left side, is still 1 plus secant of x. And now I can transfer this cosine of x over cosine of x to 1. And I also know what 1 over cosine is, and that is secant. So remember, you're trying to get the left side to look like the right side, be identical. And I'm done with this one. I can stop here. Okay, look at number 8. I have a left side and a right side. Got to figure out what we want to do with those. First thing that I'm going to do is I'm going to get rid of all the secants and the cosecants and put those in terms of sine and cosine like we've talked about in the past. So this first one here on the denominator is secant squared. So I could rewrite that as 1 over cosine squared. Similarly, I can rewrite this one as 1 over sine squared. I still have equals. I'm still going to leave this sine squared, and then I'm going to rewrite this secant squared as 1 over cosine squared. All right, next thing I want to do is I want to try to put these two fractions together on the left-hand side. So in order for me to do that, I need to have a common denominator. So I still have my numerator of 1. In terms of my common denominator, I need to have the common denominator of the two of them together. Well, the two of them together would be the product of those two. So cosine squared x times sine squared x. In order to get this fraction here, the first fraction, to have that, I had to multiply by sine squared x. So I got to multiply that on the top. Again, because we're trying to put these two together. So sine squared times 1 is sine squared x. Then I've got a plus sign. And this one I had to multiply by cosine squared x. Cosine squared x. So I have plus cosine squared x. I'm also going to leave the right-hand side as it is for right now, and we'll kind of work that as we go to see if we can adjust something in the end to make them similar. All right, then I'm still looking at the left-hand side, and I look at this, and I look at one of my Pythagorean identities, and guess what that equals? That equals 1. So this new numerator is now 1. The numerator that's in the denominator, if you're trying to be more specific. Remember, when I'm taking this 1 here that I have, and I'm dividing by some fraction, I can actually take that 1 and multiply by the reciprocal of my denominator, or the reciprocal of that fraction. Well, the reciprocal of that fraction is cosine squared times sine squared of x over 1. Similarly, I can do that same thing with the sine squared on the right-hand side, because now I'm trying to kind of work the system here so that I can get them to equal and not have to write so much work. So over here, then I'm going to multiply by the reciprocal of this fraction. So I'm going to multiply by the cosine squared x over 1. And now, if you notice, on the left-hand side, I'm taking this and multiplying by 1, which is just that, cosine squared x, sine squared x. Over here, I just am multiplying the numerators and the denominators, which the denominator would be 1, and I have sine squared x, cosine squared x. Now, you can multiply in either order. If you really want to rewrite both of these so that they're in the same order, so they look identical, you can do that. I probably, if I was doing this problem, would have stopped here and said, good enough. But once you take a look at these, the left-hand side is identical to the right-hand side, so this is your stopping point. Once you get that, you don't have to go any further. All right, let's go to number 9. Again, kind of the key things here is try to get everything to sine and cosine as much as possible and kind of work the system that way. So first thing I'm going to replace is the secant. I'm going to replace that with 1 over cosine of x. The secant here, the cosecant, excuse me, I'm going to replace that with 1 over the sine of x. Cotangent, I'm going to replace that with cosine of x over sine of x. And I'm not too sure if I want to replace this yet, so I'm going to leave this for a second and just kind of see where the left-hand side takes me. First things first, I'm multiplying two fractions together, and I don't need common denominators. I can multiply any two things together. So when I put these together, that gives me 1 over cosine x, sine x. I still have this denominator, so that cosine of x over sine of x. You're going to get so good at writing that. I still have the right-hand side of my equation, but that's not something we need to worry about right this second. So now, think about this as two fractions. Here's my first fraction divided by my second fraction. I can actually multiply the first fraction by the reciprocal of the second fraction. So what I'm doing is I'm taking 1 over cosine x, sine x, and I'm multiplying by the reciprocal of this fraction, which is sine x over cosine of x. Again, still have this tangent squared x plus 1, and I'm bringing that along for the ride until I can figure out what the heck that means to me. So next thing that I need to do is look at the left-hand side. On this side, I should be able to cancel out because I'm multiplying the sine x and the sine x. So now I want to put these two fractions together. I'm multiplying. The numerator is 1. I have cosine times cosine in the denominator, which makes cosine squared x equals tangent squared x plus 1. Now, there's a couple ways you can end this, right? I know what this is. This should be the secant squared x equals tangent squared x plus 1. If you take a look back or have those trig identities memorized or kind of in your brain, this is one of them. Okay, so you could probably leave it like that. You could also rewrite and say tangent squared x plus 1 is secant squared x, and this is probably the one that I would stop at so that they are identical. Again, either one would be acceptable because this is one of your trig identities, one of those identities. All right, last one here is number 10. Take a look. Starting on the left-hand side, we've got this cotangent. I'm going to rewrite that as cosine of x over sine of x. This one actually goes really quick. And I have the sine of x. I'm going to put that over 1. Also, take a look at this numerator over here. That one should be a trigger for you because that's a Pythagorean identity. Look at your little sheet that you have. Cosine squared plus sine squared equals 1. So now I have 1 over the secant And maybe I'll stop there. I don't know. All right, so then I'm going to look at the left-hand side here, and I'm going to recognize that this sign, because I'm multiplying, can cancel out with this sign, and so now I have cosine of x. I also want to recognize on the right-hand side that 1 over secant is the same as cosine of x, and by golly, I'm done with that one as well, and I'm down to cosine of x equals cosine of x. All right, get your homework done, try your best, and get those trig identities in your brain.